Generally speaking, it is better to know than not to know. And in networks and systems, we can use the concept of AAA, authentication, authorization, and accounting, to help control who can do what on the network and on the systems, as well as creating an audit trail and accounting record of what they did. So let's consider this topology right here, and let's imagine we have a brand new user who's going to be logging on to this computer right here, computer 2. And let's imagine that new user is Bob. What we could do is we could create a user account and set up the password for Bob on that local computer, computer number 2. And that would be referred to as local authentication. One of the challenges, though, with local authentication is it doesn't scale very well. What if Bob is at the branch office one day and needs to log on to a computer there? Or what if he has multiple devices that he wants to log in from? It doesn't scale well if we have to create local user accounts in multiple places for Bob. And then if he has to change his password or we force a password change, that becomes unmanageable as well. And so to the rescue, we have a concept of single sign-on. Sounds like something that a person might do if they're logging on to a dating application, single sign-on. In a network environment where we're using single sign-on, what we do is we have some type of a server and we create the user account for Bob along with his password on that centralized server. So in that case, Bob logs on one time, proves who he is, and then gets access to all the resources in that domain or in that space that he's been given rights to. And one of the most popular network operating systems that corporations use that use single sign-on is Microsoft's Active Directory, and behind the scenes it leverages Kerberos. Now imagine we have a user out on the internet named Lois. Now she's an employee of our company here, and she wants to remotely connect to the corporate resources. So what we might do is we might enable our firewall to act as a VPN server, and then have Lois build a remote access VPN to the firewall. Once again, we have a problem with scalability, because if Lois has to log on here to the firewall, we could create the user account for Lois here and her password. However, if there's multiple firewalls or multiple locations that she has to connect to, we don't want to have to run around to all those VPN devices and locally on each of those devices configure the username and password for Lois. Instead, we can leverage a centralized AAA server. A popular example of this would be a Radius server. So in our topology here, let's have this internal server act as a Radius server. And with Radius, we could go ahead and configure the firewall to be a Radius client, making a request over to the Radius server. And that way, if we had all the user accounts on the Radius server, the firewall does not have to be locally configured with information about Lois. Lois connects, she authenticates, the firewall says, hold on a nanosecond, and it runs over to the Radius server using the Radius protocol and says, hey, I've got this user logging on, she claims to be Lois, here's some information regarding her password, does she check out? And if the answer is yes, the response comes back from the Radius server, at which point the firewall could go ahead and grant authorization for the Lois VPN connection so that she can build that VPN and gain access to those resources that she was after in the first place. However, even with a Radius server, we still have the possibility of creating the Lois account twice. Once instead of Microsoft Active Directory, if that's what we're using, and then once on the Radius server. And that's also a pain. We don't want to have to keep track of the same user account and manually configure it in multiple places. So here's an idea. Instead of creating the Lois account again on the Radius server, she already exists in Active Directory. What we could do is we could go to the Active Directory server and simply enable LDAP. That's the Lightweight Directory Access Protocol. And we could have our Radius server acting as a client making requests to the LDAP server. And that LDAP server could respond back to our Radius server regarding credentials. So if we're running the plain Jane non-encrypted version of LDAP, that runs on port 389. Or if we're using the secure version of LDAP, LDAP-S, that uses port 636. And the big picture would look like this. Lois connects to the firewall who's acting as a VPN endpoint. The firewall is configured to use Radius, so it checks with the Radius server regarding the credentials for Lois. The Radius server is using the Active Directory with LDAP. So the Radius server makes its request over to the LDAP server. And then as the responses come back, the Active Directory LDAP service would respond back to the Radius server, who would then respond back to the firewall with 2 thumbs way up, assuming Lois had the right password. And then that VPN tunnel for Lois would be built and established, and then Lois could continue to access those things that she's authorized to reach and use. And let's reuse that idea of leveraging a centralized server one more time in the case of TACACS Plus, which is a Cisco proprietary protocol, and it's used primarily for the authentication, authorization, and accounting of administrators. So let's imagine that Jim is the administrator for the network, and Jim needs to connect to the switch to do some management. Jim needs to connect to the router and to the firewall. If we have this internal server that's also acting as a TACACS Plus server, each of these devices, the switch, the router, the firewall, could act as TACACS Plus clients whenever Jim connects to authenticate, and they would make a request over to the TACACS server, who would then say yes or no. And because TACACS Plus is proprietary for Cisco systems, it's likely we're only going to see that for the management of network devices and only if those devices happen to be Cisco. And in all of these cases, we want to authenticate the individual to identify who they are. And once we know who they are on the network and on the system, the authorization controls will limit what they're allowed to do and where they're allowed to go. And we can use the same type of systems to also build accounting records regarding who connected, who authenticated, and what they did. And that's very helpful if we ever need to go back and do auditing to find out what happened in the event of an incident or a problem on the network. I'd like you to imagine that it's Thursday morning and you and I are going into work, and as we go up the elevator and we go over to our offices, standing by the doors of our office are some senior executives. And we're not in trouble, but they are asking some questions. They had read some articles about at other companies how somebody had acted as an imposter and logged in as one of their users and was able to access systems. And so their question for us is, how do we verify that our Bob, the real Bob, is the real person that's logging in? How do we increase the validity that it truly is Bob and not some imposter? We could use something called multi-factor authentication. And to understand multi-factor authentication, let's create 3 categories. And we'll give them letters: Category A, Category B, and Category C. In fact, we could call these 3 categories factors. So Factor A, Factor B, and Factor C. And in Category A, we could say that this is something that Bob or the user knows. Examples of things that Bob might know would be, for example, his password or passphrase. So in our environment, if we're requiring Bob to log in, so he types in his username of Bob, and then Bob types in his password, the password is something that Bob knows, and that would be considered, if that's all that's required for Bob to get in and be identified by the system for him to authenticate, that would be considered single-factor authentication, because we're only using a single category. In this example, it's something that Bob knows. If we wanted to kick it up a notch and really make sure it's Bob, we could require not just something that Bob knows, but also maybe something that Bob has. A great example of this would be going to the bank. If we're going into the bank, it's very likely that we have a bank card, a physical bank card that we can run through a card reader. That would be an example of something that we have, or that the user has. Now, in addition to that physical card, which would be using something from this category here, something the user has, there's also normally associated with that card a PIN number. And that PIN number would be something that the user knows. So if we're using 2 or more factors from 2 or more different categories, it's referred to as multi-factor authentication. Now, another factor that we could use besides something that Bob knows or something that Bob has is something that Bob is. And when we talk about this category, we're talking primarily about biometrics, like an eyeball scan that may be looking at retina information or iris information, or a handprint scan, or a finger scan, or facial recognition. Those are all examples of the factor or category regarding something that the user is. So what we could do, if we wanted to go ahead and require one of each of these categories, that would still be considered multi-factor authentication. For example, for Bob to go ahead and get access on this computer, he might have a password that he has to supply, or he may have some type of a token like a key fob that generates a number. That would be considered something that Bob has. That's also required as part of his login process. And if there's a fingerprint reader at this computer, and that is also required, that would also be an example of multi-factor authentication. However, you don't have to use all 3 categories. You can use just 2 of the 3 and still have it be considered multi-factor authentication. Let's say if Bob is going to log in, he has to know his user ID, he has to know a password, and he has to choose the correct picture. It's going to show him 15 different pictures, and he has to choose the correct picture based on what he selected originally when he got set up in the system. Let's say also that there's a 4-digit PIN also required. So he has to have a password, he has to click on the right picture, and supply a PIN. Now, is that an example of multi-factor authentication? And to determine that, we have to look at each one of these. The password is something that Bob knows, so that's in category A. Choosing the correct picture from a set of pictures is also something that Bob knows from category A. And the PIN number is also something that Bob knows. And the fact that all of these are from category A or from a single factor, even though it's more secure than only using a password or only using a PIN, because these are all from the same factor, the same group regarding something that Bob knows, this is an example of single multi-factor authentication. We have to choose from at least 2 or more of the different categories of factors for it to truly be multi-factor authentication. So let's start off with the main question, why? Why would we ever want to go to the extra steps of using multi-factor or two-factor authentication? What's it going to get us? And the answer is hopefully something like this. This happened to me earlier today. I logged onto an account I hadn't logged onto for a while, and it said, success, you last logged in 5 months ago, and in the meantime, since your last login, there have been 42 failed login attempts. And then it says, good thing you have two-factor authentication enabled. And by George, it is true. If I had had a weak password or even a tough password that was broken and didn't still have the two-factor authentication in place, that means the bad guy, the attacker, would have been able to log in as me and then do whatever he wants with that account. So the good news here is that if we're using two-factor authentication, it's going to make it tougher for an unauthorized individual to log in as us. So the next question that might be asked is, okay, I get it that we want to improve our security, make it tougher for a bad guy to log in as us, but how do we go about it? Now, if you're at a company that has implemented multi-factor authentication, it's very likely going to require something that you know, for example, a PIN or a password, along with something that you have. For example, a code like this one right here. Now this little key fob right here generates a new 6-digit number every 60 seconds. And here's an example of how it would work. If we're logging in, it'd be asking us for our username and our password. We'd supply that. And then we'd have another section that comes up and says, okay, what is your 6-digit authenticator code? And so what we would do, we'd look at our key fob and we'd go ahead and type in these 6 numbers that we're currently showing on this screen. Now, if we were almost out of time, and over here on the left, it indicates how much time is left. If we're almost out of time and it's about to regenerate, we don't need to rush it. We can just wait for a few seconds. It'll automatically generate a new number, and then we type in that new number. The idea here is this is going to be used for a single time, this 6 digits, similar to the concept of a one-time password. And on the other side of whatever you're logging into, they have the ability to check to see whether or not the numbers that you put in as part of this multi-factor authentication is correct. And one of the cool things is these objects that generate the numbers, they don't have to be physical. We also have apps that can do it. This is Google Authenticator. And here we have another vendor which has a similar mechanism that generates a 6-digit code based on where you're trying to log into. And as a result, the user has to supply the password along with the 6-digit code when they log in. So that way, even if the attacker does steal a password by itself, if they don't have the one-time password, the code to put in, they won't be able to log in, even if they have your password. Another mechanism that can be used by multi-factor authentication is a card that has a little chip in it where you actually slide the card into a reader, where the card is an example of something that you physically have, and that in combination with the password that the user knows would both be required to log in, and that would also be an example of multi-factor authentication. Now, another big question that comes up here in the how camp of implementing multi-factor or two-factor authentication depends on where it's happening. If it's at work and we have an IT department that's mandated multi-factor authentication, we'd simply follow the instructions that they've given us. So we'd use the Google Authenticator or the LastPass Authenticator or the physical key fob if they've issued one to us. And the IT department in a company would have instructions or information regarding getting it all to work inside of that company, inside of that corporate environment. Or if we're doing this on our own, for example, we would download the app of our choice. For example, here's Google Authenticator. Here's the LastPass Authenticator. They both work very similar. And then what we would do is we'd go to the site. For example, if we have a Google account that we're using for Google Mail and for other features, and we want to protect that with multi-factor authentication, we would go to the settings of our account at that site, at Google. We'd go to the security section, and that would walk us through how we can add an entry, for example, just for our Google account in our Authenticator. And then once it's enabled for our account at Google, when we log in, it's going to ask us for our username, our password, and also it's going to ask us for a 6-digit code that's associated with our Google login. And then once we supply it, we log in and we're off to the races. And again, the purpose is to help make it tougher for an unauthorized user who doesn't have access to our one-time password that's being generated by the authenticator. And as a result, it prevents unauthorized access and unauthorized logins against our accounts. To demonstrate the setup of two-factor or multi-factor authentication, I have a temporary user account, and the user's name is Aiden. I just created him a while ago just for this demonstration, and currently Aiden has only a password required to log in as Aiden. So for example, if we click on Gmail right here, it's asking us to authenticate to provide the password for this Aiden user, which we'll supply. And with that password supplied, we'll click on Next to continue. So to add the multi-factor authentication with either Google Authenticator or a similar product, we would download that application. For example, Google Authenticator or LastPass Authenticator to our smart device. So in the case of Aiden's account here, we'll go ahead and click on this little A up here for Aiden. And we'll click on My Account, referring to Aiden's account. And then we'll scroll down a little bit, and we have an option here for signing into Google in the Sign In and Security section. So we'll go ahead and click on Signing into Google right here. And as we scroll down through our options, here we have an option for two-step verification, which is currently off. So what we'll do is we'll go ahead and click on this little greater than symbol over here on the right to edit those settings. Here it's indicating that to set up this two-step verification, that'll be required when we log into our Google account, we'll need our password, the current password for Aiden, also a verification code that they're going to send. So we'll scroll down and we'll click the button here for Getting Started. So it wants to make sure before we add this two-factor authentication, it wants to make sure that we are really Aiden. So we're going to put in the password for Aiden, which I've just done, and then we'll click on Next to continue. Next, it's asking for the phone number associated with Aiden's smart device, for example, his smartphone. So for the demonstration, I'm going to put in my phone number because I want to actually set this up and have it work. And if you were setting this up, you'd supply the phone number associated with your smartphone. So I supplied my phone number, and now it's asking me, do I want a text message or a phone call? So I'm going to go ahead and leave the radio button for text message selected and click on Next. So now I'm supplying the code that just got texted to me to my phone number, and then we'll click on Next to continue. It's verified that I really do own that number. So to turn on two-step verification, we'll click Turn On to turn on the feature. So the feature is on for two-factor, and the two factors are going to be Aiden's password and the text message that they'll send to Aiden's phone when he attempts to log in. And without both of those pieces, he won't be able to log on. And more importantly, without both of those pieces of information, the attacker won't be able to log on as Aiden. However, it gets better. Let's up the ante by using an authentication app like Google Authenticator or LastPass Authenticator instead of getting an SMS message from Google every time we want to log on. And to do that, we're going to scroll down, and it's providing us several options here. And the one we're going to choose is setting up an Authenticator app. So we'll do that right now. We'll click on Setup to continue setting up the Authenticator app. And it's asking what kind of phone do we have. It looks like there's only one choice there, but that's because my window's a little small. If we scroll down a little bit, we're going to specify the type of phone that we have, Android or iPhone. And for this demo, I have an iPhone, so I'm going to click that radio button. Click on Next. So now it's generated this barcode for us, this QR code looking thing. And what we would do is go to our Authenticator app, whether it's Google Authenticator or something similar, such as the LastPass Authenticator. We click on the plus symbol in the app. We then click on the icon of the camera, which represents we want to take a picture of it, and that will go ahead and add that as an entry for Aiden into our Authenticator app. So I'm going to do that right now with my phone being held up. I'm scanning this picture of this barcode, and that added it as an entry here inside of my Authenticator. It's also right about now that if you have two different smart devices, for example, a tablet and a phone or two phones, it might not be a bad idea to have this entry in more than just one device. That way, if you lose your smartphone, you can still get your passwords from the Authenticator app that's still running on the other one. So to facilitate that with the app running on both of our smart devices, we'd want to create entries on both devices by having the Authenticator app on each device scan this barcode. We'll go ahead and click on Next to continue. Now, before it turns on this feature of requiring the Authenticator code to log on, it wants to make sure that we got it right. So it's asking us to look at our Authenticator application and supply the 6-digit code that's showing up right there for that account. So I'm going to wait just a few seconds till it generates a new code. And now with the new code, we'll go ahead and type it in. And that code at the moment is 516131. And with that supplied, we'll click on Verify. And it says, great, you're all done. From now on, when you log on, it'll require the password for the Aiden user account. And in addition, as part of the two-factor authentication, the user will also be prompted to supply the current 6-digit code before the logon will be successful. So we'll go ahead and click on Done. The other thing that we may want to do while we're here is verify that it works. So I'm going to go ahead and close this tab for the settings, and we'll also go ahead and log out as Aiden. So we can do that by clicking on the A up here for Aiden and clicking Sign Out. So we're currently logged out. So now if we want to log on as Aiden, we'll supply Aiden's password, and we'll click on Next to continue. And now it's asking us for the verification code from the Google Authenticator app. Now, what I did is I didn't use the Google Authenticator app. I actually used the LastPass's Authenticator app. which supports the same functionality. So if I go to that app and I open it up, the current code for that user account is 255437. So we'll supply that, click next, and now we're logged on as Aiden. And we also have an email from Google saying, hey, you turned on two-step verification, which indeed we did. In the world of access control, one of the things to do is to stop a person or an entity before they get too far into the system. And one option we have for doing that is port security on a layer 2 switch. Check this out. Let's use this topology right here. And let's imagine that we're worried about this user sitting at computer 1. Now, computer 1 is in an office or a cube, and they've got a cute little patch cable that goes to the RJ45 jack in their office that leads to the port on the switch. And what we can do is, if we're worried about that user disconnecting his computer and connecting instead another switch with multiple ports. So maybe this user in his office wants to connect 6 or 7 devices, just connecting another switch will expand the number of ports, and then he can connect additional devices. Now, if we want to stop that from happening, or at least stop him from successfully communicating on the network, all we do is train the switch port on the switch. Hey, buddy, check this out. 1 MAC address only, like Hunt for Red October with Sean Connery. 1 ping only. So if we train the switch that the maximum number of MAC addresses that it should be able to learn off this port is 1, and if there's any more than 1 MAC address, it should have a violation and shut down the port. That would prevent this user from successfully connecting the switch and then connecting multiple devices, each with their own MAC addresses, to that port via the external switch he has in his office. Now, before we rush out and do this, somebody might ask, well, what if he's got some virtual machines, or he has an IP phone, or he has a few MAC addresses on that port? And I get that too. So what we might want to do is we could set the maximum number to 5 MAC addresses. And if you go to 6, we're going to have a violation. And that violation could either be to shut down the port, or it could be to simply restrict any MAC addresses over 5 on that port. And that's going to help us right from the get-go with access control regarding allowing multiple devices in on a single access port. Now, not every switch vendor supports the features of port security. And so depending on the type of switch you're working with, the commands might be slightly different. Here we're going to do a demonstration with a Cisco Catalyst switch. So what we do is we go into global configuration mode with config space T, or configure space terminal, however you want to spell that. And then we'll go further into interface configuration for gig 0/0, and we'll enable the feature with the command switch port space port dash security. Ta-da! It's enabled. So it's enabled with some defaults, including a maximum number of MAC addresses of 1. So if we want to allow more than just 1 MAC address, we can change that. We'll set it to 5 with the command switch port dash security maximum 5. And we can also specify the violation action in the event that more than 5 source MAC addresses show up on that port. And we can do that with the command switch port space port dash security space violation space, and then we'll use the command shutdown, which informs the switch, hey, if there's more than 5 MAC addresses, shut down this port. It's interesting that if somebody came up to our door, it's very likely they're going to knock on the door before they just come right in. I mean, we're not going to have a sign on our door that says, please come on in, and then tell us who you are. It's going to be the other way around. We want to know who that person is before we're going to let them in. Well, on our networks, we can take the same approach of finding out who individuals are before even giving them access into the network. And it can be implemented with a technique called 802.1x. And this can be applied to physical environments with Ethernet switches. And we can also apply the same kind of technique for wireless access into our networks. And the basic concept is this. When Bob is connected to the network, instead of just giving him access to everything, we can have the switch acting as an authenticator. Think of authenticator as a challenger, the entity that's asking for credentials. And so Bob over here on his computer would have a supplicant, which is a piece of software that can interoperate and work with the authenticator. So when Bob connects, the authenticator working in conjunction with a AAA server, for example, this could be a Radius server, are going to request Bob to authenticate. And as part of the authentication, Bob may have just a username and password, or if we're doing multi-factor or two-factor authentication, we could be requiring multiple things from Bob to verify it's really Bob. In the case of multi-factor authentication, maybe Bob has been given a smart card, and on that card there's a chip, and on that chip there's an individual certificate for Bob. That would be an example of something that Bob has. He has both the card and the certificate. So if there's a card reader that's attached to this computer, when he logs on, he can supply his username, the password, which is something he knows, and also the certificate being read in the card reader as something he has. And if that all checks out, the authentication server gives a message back. Great, let him in. And then Bob has successfully made it past the switch, and he's now on the network. And this type of technology can be extended further with solutions including NAC, Network Access Control, where the client, Bob in this case, and his computer are not only required to authenticate, but we can also profile that computer or that device to make sure it's compliant and secure enough to even connect to our network. Or based on who that individual is, once we authenticate him, we might have access control lists that are dynamically placed just for that specific user that control what he's allowed to access as he's communicating over the network. And 802.1x can be used in combination with other functions and features. For example, if we're looking at our logs and we see that there are specific MAC addresses that have been trying to get in or access our network, we could set up MAC filtering that would prevent specific MAC addresses from getting access into the network. And we could do that on wired networks. We could also do it on wireless. And the concept that's presented by 802.1x regarding stopping an individual and validating them before we let them continue is a great concept to help us enforce security and access control. And another common example that we're going to see in hotels and coffee shops is the concept of a captive portal. And that's generally done with wireless. So a user connects to the access point, and then before they're allowed to get their traffic out to the internet or out to other networks, they have a pop-up that comes up that forces them to either identify themselves or agree to terms before they're allowed to continue. So that stopping point before we allow them to continue would be an example of a captive portal. And if the user doesn't agree to the terms or can't supply the information required, we simply stop the user at that captive portal and don't let them continue anywhere past that.
Thanks for watching our second, and press the button below, like, subscribe, and bell icon.